Hello, it's Mr. Norris. The purpose of this video is to be able to think about the distance from one point to another point, and we're going to do that by talking about the distance formula. I want you to consider this blue line that we've drawn on the graph. We're going to label one point on the end of it point A, and A is going to be x1, y1. We're doing this because we want to speak in general terms. We don't want to give it its actual ordered pair, which is 1, 2. We just want to think about it in general terms. So we're going to do the same thing with this other point on the end. We're going to think about that as B, and that's going to be... Actually, let's use a different color for that. We're going to call B x2, y2. So the idea is to be able to find the distance in general between these 2 points. So we're going to think about this in 2 separate ways. We're going to think about the horizontal distance, and we're also going to think about the vertical distance. So the question is, what is this vertical distance? I'm going to draw a dotted line there to indicate that distance. So I have my dotted line in black. Well, what is that distance? Oops. Well, it's going to be the difference between y2 and y1. That's what this length is. So let's go ahead and write that out. The difference between y2 and y1. Okay, so we have that for our vertical distance. Now we're going to think about the horizontal distance, the distance between A and B going from left to right. That, can you think about what it might be? If this is y2 and y1, what do you think is going to go down here to represent that distance? Well, it's actually going to be the difference between x2 and x1. So let's go ahead and write that out. We're talking about the difference between x2 and x1. So let's think about what we have here. We have a right triangle, and the length of the hypotenuse we're just going to call d for distance. We have the distance of a leg represented by x2 and x1, and the distance of another leg represented by y2 and y1. So we can use the Pythagorean theorem to find d. Let's go ahead and set up an equation for that. I'm going to zoom out just a little bit. Okay, I'm going to zoom out just a little bit, put this up here in the corner, then we're going to do some algebra. So we know that d squared is equal to x2 minus x1 squared plus y2 minus y1 squared. This equation uses this information for our graph, our diagram, but it takes the general form c squared equals a squared plus b squared. So all that we've really done is use the Pythagorean theorem. Now let's reconsider what we're looking at in black, and let's write out our final conclusion. So I'm going to zoom out just a little bit more. Okay? So now ultimately all we have to do is think about how we're going to get rid of this to the second power. Once we did that, we would have our distance by itself, which is what we want. So let's go ahead and write that out. We're going to take the square root of both sides. So square root of d squared equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And we know that the square root of a value raised to the second power is just that value itself. So all that we've said is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So ultimately, we found our distance formula. The main thing that I want you to recognize from this is that the distance formula is a direct product of looking at this diagram and then simply employing the Pythagorean theorem. Let's talk about how we might use this in actual problems. Consider a line that exists on a graph with the following points: A is negative 1 comma 3, and B is 2 comma 1. If we wanted to find the distance from point A to point B, all we would have to do is use our distance formula. So we would go ahead and write that out. D is equal to, you never forget the square root, of x2 minus x1 squared plus y2 minus y1 squared. So let's think about what we're working with. What's x2 and x1, and what's y2 and y1? Well, let's go ahead and write out those points. So I have negative 1 comma 3, and I'm also working with 2 comma 1. Now I have some choices. I can say that this is going to be x1, and that's going to be y1, and that this is going to be x2, and this is going to be y2. Or I could reverse that, and I could choose the option in green, which is going to be that this is x2, and this is y2, or that this is x1, and this is y1. I can either choose the option in green or the option in red. They'll both work. For the problem down here, I'm actually just going to use the option in red. So let's go ahead and fill in our information. So D equals, take the square root of everything. x2 is going to be 2. Then I'm going to take away negative 1, since x1 goes with negative 1. Then I'm going to say plus 1 minus 3. Raise that to the second power, and I have what I need. Okay, let's zoom out just a little bit. So now what I want to be able to do is to go ahead and simplify this. So we're going to have D equals square root of. Now I know that 2 minus negative 1 is not 1, it's actually 3, because this is saying the same thing as 2 plus 1. So I'm going to have this as 3 squared plus 1 minus 3, that's going to be negative 2 squared. I can simplify that a bit more, and I can get D is equal to the square root. 3 squared is 9. I'm going to do plus 4, since negative 2 squared is 4. I'm going to set that equal to square root of 13. It's perfectly acceptable to leave square root of 13 as your answer. If you want to put that in your calculator, you're going to get a decimal value that's going to be somewhere between 3 and 4. But you don't have to write that as a decimal unless you want to. This is a perfectly fine answer. That means that this line that we were originally looking at is somewhere between 3 and 4 units long.